Over 15 days in November 2018, the Woolsey Fire burned almost 97,000 acres in California. So today we're going to take a little field trip to that burn site near Malibu in the Santa Monica Mountains. The United Services Automobile Association, USAA, needed to identify damaged and undamaged buildings in this area to process the claims of its customers, and it had to happen as quickly as possible because people lost homes. So in the aftermath of a natural disaster, response and recovery efforts can be drastically slowed down by manual data. You can have people go out to the sites, analyze the damaged buildings, and then go back to their computers and manually input this data into GIS by creating and editing features, something that we all know how to do, right? Depending on the scope of a disaster, this process can significantly delay relief to disaster victims. So the USAA used the deep learning capabilities of ArcGIS to quickly identify these damaged structures within the fire perimeter. This information allowed insurance adjusters to fast-track the claims of affected residences and businesses. The process of capturing training samples, training the deep learning model, running interference, categorization tools, and detecting damaged homes was accomplished entirely within the ArcGIS platform. Model builder graphically illustrating the deep learning tools we'll need to run in order to do something like that. So today we're actually going to replicate that analysis, and we're going to use the deep learning tools in GIS. So last week we looked at image collection, like object identification, change detection, and today we're actually going to put it to use and put it into a practical real-life example. So if you've downloaded the data from Canvas and opened ArcPro, you'll see that you already have some building features and training samples loaded and the raster image. So we're looking at Malibu right now. And so the first thing I'm going to want you to do is let's go ahead and look at the attribute table for training samples. We'll click it open by right-clicking on the layer and selecting attribute table. Okay, so here we have all our buildings. Right now they're symbolized as damaged and undamaged. And for creating a deep learning model in GIS, you need to start with manually entered data. So you have to tell the system what a damaged building looks like and an undamaged building looks like. So then it can learn and do it for you. Okay, so we have the training samples attribute table open. And in this first step, we're going to review the building footprints that have been classified as damaged or undamaged to ensure that they are accurate for training a deep learning model. We don't want to input inaccurate data. So for the purpose of today's exercise, the building footprints have been provided. So their training samples are the building footprints that have been classified already. But if you were to start this project on your own in a different area with just aerial footage, you could just start a feature class and start making polygons of the buildings and classify them as damaged or undamaged. And that could be your input for a new deep learning model. So once you have this training sample attribute table open, let's click the fields 3 horizontal bar icon in the top right, and then select fields view. And then you could see here, if we scroll to the right, we see something called domain, the column. And then here is where we've put class_value. So the attribute domain defining list of valid values is right here, and it's for the class value attribute, which is a short data type, and that's a number format. So the class value field is used to classify the building as damaged or undamaged. It has a domain named class value that I just went over, and this controls the values that can be entered for this attribute field. So you already know the 2 classes that are used. So on the ribbon from the Fields tab, Fields, and then we're going to go to Data Design Group. Let's select Domains. And then over here on the right, we see the code 1 and then code 2, and then the description is damaged or undamaged. So these domains appear once you click domain, and it displays all the domains for this project's geodatabase. This may not seem very important, but it really is, because for the deep learning models, they only take into account numbers. They can't take in text. So we defined what number goes for what description, but the model itself will take in the numbers. So this seems like a small detail, but the deep learning model that we will create uses numeric values only. So that's why this is really important. So we can close the domain table now. And now that we understand how the values are being stored, we will ensure that the training sample polygon properly classified. On the ribbon from the Edit tab, so we'll go to, wait a sec. Let's close the fields training samples. And then on the Edit ribbon, there we go, let's select attributes. So it should be this icon that looks like a table, and it will be labeled attributes. I'm going to make mine bigger. And so we have two different tabs up here, selection or layers. We're going to select the training sample layer, and we'll start at the top. And so what this does is it shows all the attributes within the table, and then you can progress through these features in the layer and update their attributes. So if we start at the top, the object ID should be 1, which it is. And then let's go through each one for just to practice and make sure that they are labeled correctly. So let's go to the next one. And this should be undamaged, and I'm sorry, this should be damaged. And if I look over here, it does say damaged, so that looks good. So this is how you can kind of check your manual work. Just keep going through, making sure if it's undamaged, then it truly is undamaged on the aerial, and so on and so forth. So let's scroll to object ID 8. Okay, and you could check from attributes, it should say 8, and you can also click it in the attribute table, because there's more than one way to do something in GIS. You can also do that. So it is labeled as undamaged. So maybe it's hard to see with the training sample layer on, if I unclick it, does that look undamaged? No. So this was labeled incorrectly. So now we're going to correct this by going over to the attributes table and then selecting damaged and then apply. And so then we'll see that this class value changes to damaged. And so let's go through object ID 9 and 10 because those are also incorrectly classified. And so let's correct those for practice. So again, this says undamaged, but it's clearly damaged. So we're going to change that and select apply. And then go to the next one. This one says damaged, and if I turn this layer off, I could see the building is still there and not damaged. So then we're going to switch it to undamaged and then apply. Okay, and we'll go to the next one just to be safe. This is object ID 11. It's classified as damaged. That certainly. Okay, and actually in looking at object ID 11 and its surrounding sites, you could see that the burn line stops right here, and you could even see green vegetation. So this actually is considered undamaged. So we will change that as well, and then select apply. So that's why this manual check, especially with training samples before we run the deep learning model, is really important. So we want to teach the model the right object identifications. Okay, so in the quick toolbar, we're now going to we already select apply, and then we want to click save because we just made edits. Save all edits, yes. Remember to save early and often. So now that we have 1,252 training samples, you don't need to do that many. I've just supplied that many for today's exercise. If you wanted to do your own object identification, you could do a couple hundred. Also, there's building layers for local government websites that are just downloadable, so you don't actually even need to do this, but you would need to go through and classify each one, but you don't need to make the polygons in most cases. Okay, so the next part of today's exercise is to export training samples. So a deep learning model cannot process the raw aerial imagery and the training samples polygons. Instead, you will split the image into smaller tiles called image chips and convert the polygons to labels. The chips are smaller pieces of imagery for the software to process, and the labels will match the different classes of features that you identified as either damaged or undamaged. So in this step, you will use the export training data for deep learning geoprocessing tools to perform this action. So let's go up to the analysis ribbon and select tools. I actually already have them selected, but it probably takes you to your favorites by default. So if you could type in the search toolbar, or you could go to toolboxes, and under system toolboxes, you'll scroll down to image analyst tools. Let's click that drop down arrow. And then here are all the image analyst tools that Esri provides. So we have change detection, which maybe some of you want to use for your semester project, and other tools that are labeled here. But for today, we're going to click deep learning. So let's click that toolbox open. And then we want to look for the export training data for deep learning. And that is towards the bottom. It's called export training data for deep learning. And then go ahead and click that open. I'm going to make this bigger so you could see the tool, the geoprocessing tools. So when selecting the export training data for deep learning geoprocessing tool, ensure that you choose the image analyst tools and not the spatial analyst tools. That's a really common mistake, so you want to make sure you're selecting the right tools. In the geoprocessing pane for input raster, choose USAA imagery. Okay, so that comes with the Esri, the ArcGIS project that you've downloaded from Canvas. Next, you will input the feature class of buildings and the attribute field that identifies each building as damaged or undamaged. So for input feature class or classified raster or table, let's select training samples, which is this table that we just went through. We went through the features. And then for class field, let's choose class value, because that's the field, as we know, that has damaged or undamaged. So class value. So the next set of parameters are tile size, is used to make the chips created by this tool bigger or smaller. So this default size is 256 by 256 pixels, as you could see. You will make these chips larger. So the stride value determines how much overlap there is between the image chips that are created. By default, each chip overlaps by 128 pixels, which you see here. Increased overlap will increase the number of chips created. You will only update the tile size parameters right now. So for tile size X and tile size Y, let's type 448. Okay, X and Y. Now you will set the format used for this project's type of image classification. This part is really important. Depending on your deep learning workflow, you will choose the appropriate output format. For metadata format, right here, we're going to choose labeled tiles. And I will provide a link on Canvas under lectures that helps to identify image format, okay? So if you're wanting to use this kind of exercise for the semester project, you'll have to choose different models and different formats rather. But for today, we'll use labeled tiles. And then finally, you will set the cell size for the tool to use. A deep learning model performs best when the training and prediction images are of the same resolution. Cell size is the dimension of the image pixels in real-world units. For instance, if you are using a projected coordinate system with linear units of meters, setting the cell size to 0.3 makes each pixel in the output 0.3 meters wide. So near the top of geoprocessing pane, click the Environments tab. So we'll scroll back to the top. Environments tab. Under raster analysis, right here, we're going to make sure that the cell size is 0.3. Okay, just like that. Now we're going to click run. But before we click run, I want to see where this is saving. Oh, and see, I didn't actually choose an output folder. So that is something I missed, which is always good to check your parameters. So for output folder, let's type building. Oh, cap locks is on. Let's redo that. Buildings, training samples. Okay, just like that. Now make sure everything looks good. Oh, and I have used selected records. That is because I have a selected record right here. I want to unselect that and then also click this off, and that'll use all the training samples. This is really a good example of why it's important to check your parameters and make sure that your attribute tables are unselected. Okay, everything looks good, and now we will select Run. So this export training data for deep learning tool, this may take several minutes to run. It's looking at a large raster layer and doing a lot of computation. So yeah, I will probably pause this recording and then come back in a few minutes to check on the status. So after the tool has ran, we have successfully exported a set of image tiles with labels that identified the buildings as damaged and undamaged. And those have been saved to this output folder. This exclamation mark yellow triangle icon is just telling me that this name already exists. So if I were to run this tool again from this window, I would need to change this name. So you could ignore that because we're not going to run it again. So in the next part of this exercise, we will use these results to train a deep learning model to automatically identify buildings in each class. So we're done using this tool. So now we can go up to the imagery ribbon and then deep learning tools and select for the command search field type train deep learning model and click that open. And then first we will use the set of exported training data from what we just did. So in the input training, set the parameters automatically. Let's do set my own parameters. Okay, input training data. So this is where we're going to navigate to the that output folder from the previous exercise. So it should be, for me, it should be classifying objects deep learning, and then buildings, training samples. So it's important to remember where you saved the last tool that just ran. And then select OK. Oh, and I'm getting a red arrow, so let's see what that's about. So that says not installed. Install deep learning framework for ArcGIS Pro. If this is the error that you see, then you need to go back to Canvas and follow the steps on the beginning of the lab activity instructions on how to download the deep learning installer. So I went back and downloaded the correct deep learning installer. And now I will select the buildings _ training samples from the tool that we just ran previous to this. And now it's looking fine. Okay, so then I will continue with the output folder. And I will just choose the default here, and it's going to go, and you can hover over this and to make note of where these tools are saving their output layers. Now you will set the number of epochs for your model to train. Each epoch is one pass of all the training data forward and backward through a neural network. The more items that you pass the data through this network, the better your results will be. Although after a while, the returns from doing so will decrease. So for max epochs, confirm that it is set to 20, which it is. Next, you will choose the type of model to produce, which is based upon the format of your training data from the previous tool that we just ran. So let's click the model type, and we want to make sure feature classifier is checked. Okay, and then we could move on. Oh, okay, then we can move on. And we want to select the batch size value. So this parameter is the number of training samples that will be processed at a time. So the batch size is actually determined based off your computer processing capabilities. So if you have a powerful GPU, then you can process up to 64 training samples at a time. I'm going to just keep the default here. I think it's best for you to keep the default, but if it doesn't run, if you have a less powerful GPU and you know that, you may have to set this parameter to 8, 4, or even 2 and rerun the tool if it doesn't work from the start. Okay, so we got the batch size. And then let's click run. So the tool will run and the time that it takes to complete is dependent upon your computer's hardware. So the training will stop automatically when the accuracy of the model stops improving or when the number of epochs reaches the specified limit. So while the tool is running, you will see how the model is progressing through the training. If for some reason you didn't run the train deep learning model, or if the tool is taking too long for you, then I've actually provided the results from this tool. So if you go into the folder that you downloaded from Canvas, classifying objects, deep learning, go to provided results. Let me move this over so you can see it. Provided results, and then buildings classify. You will see the different results in different formatting. So buildings classify.pth, that is a trained model and is usually saved in a PyTorch format. Buildings classify.emd is a model definition file that contains model information about the tile size, classes, and model type. And then model metrics, right there is a HTML file type, and it's details about the learning rate used and the final accuracy of the model. And then buildings underscore classify.dlpk is a complete package of all the files stored in the model output folder, including the training model, the model definition file, and the model metrics file. This package can be shared to ArcGIS Online or ArcGIS Enterprises as an item for others to access as well. So next, you will explore the model metrics page to see how your model performed during training. So let's double click the model metrics, and I'm just using File Windows Explorer. And so I'll just view this using Microsoft Edge, unless you have Adobe, which my computer doesn't at the moment. So here is my model underscore metrics. And because the model trains differently each time that the tool is run, your model metrics may vary, and it may not look exactly like mine right now. So locate the training and validation loss graph, which should be kind of pretty obvious. It's right in the center of the page. And then the training and validation loss section displays a graph of the amount of error that was present as the model trained over time. So when the model ran, some of your input data was used to train the model, and some was used to validate the model or test the model to determine its accuracy. Ideally, you would see these values decrease as the number of images processed increases over the course of the 20 epochs. So you can see that. And under analysis of the model, locate the confusion matrix. Let's scroll down. So here's the confusion matrix. This is a visual that shows how well the model identified buildings between the two classes of damaged and undamaged using the actual or input data and the predicted results. So, and then under sample results, here's a sample of the results from the tool. We can locate the ground truth prediction section right here, and then see the two different classes, damaged, undamaged. So the ground truth prediction section, this provides some examples of the training's results. So images are shown side by side with the known results on the left and predictions on the right. So here, let's see the first one. This was predicted undamaged, and then the results were undamaged. And so we could see that that was correct because the building is clearly undamaged. Similarly, the same situation, it was predicted undamaged and results were undamaged. And then here's a damaged one. This does in fact look damaged, and then so the results showed undamaged. So that's where there was actually some error in the model. And so this looks undamaged, and this does looks undamaged. So pretty good ratio of results, because considering these were just sample results, and there's only one that was possibly incorrect. Okay, so we can close out of this web browser tab, and then let's save our project. My tool is actually still running, so I chose to use the provided results that I provided on Canvas. And let's close this. My tool is still running, so I'm going to close it and come back when it's ran and complete. But if yours is complete, you can have this remain open and we can move forward with the last part of today's exercise. Okay, now that we've trained our model by running the trained deep learning model, we are ready to move forward to the next and final step of today's lab. If for some reason you didn't run the previous tool because you were having computer issues, this is a really GPU intensive process and it takes a lot of time. I've actually provided the results from the last tool on Canvas so that we can move forward with the lab. So if necessary, you could start Arc Pro and open your Woolsey Fire project, but you should probably already have it open. And in the contents page, let's turn off the training samples. We'll get rid of create features and modify features. Okay, so we turned off the training samples and you'll notice that there is another layer called building features. And like I said earlier, this is just a layer that you can download from most likely the local jurisdiction's website where they usually provide building layers. If not, you could create your own Polygon feature class and digitize each building. That works too. But let's turn on the building features layer and let's zoom to it so we know what we're doing here. So right click, zoom to layer. Okay. And as you zoom out, the aerial stops showing. Okay, so these are just building polygons that we have here. And then in the building features layer has additional building footprints that aren't classified yet. Maybe we ran out of time, we couldn't keep doing them manually. We want to use this trained learning model, deep learning model. So from the map tab in the navigate group, let's click the bookmarks. And then let's select inference area bookmark, which I had already provided for you. Now you will use the trained model to classify the buildings in this extent. So on the ribbon in the command search field, so in the command search, let's type classify objects using deep learning. And it should be this first one that says image analyst. So let's double click that. And that will take us to our final geoprocessing tool. So for the input raster, let's choose the USAA. Next, you will choose the features to be classified, which is that building features layer. Because those aren't yet classified. And then here's our output feature class. We'll keep the default, but if you hover over, you can make note of where you're saving this. So for me, it's in my week 13 folder and then in the geodatabase for Woolsey Fire. And then in the model definition dialog box, browse to the classifying objects deep learning folder that you originally downloaded from Canvas. And then go to buildings, so that's in provided results. Or similarly, if you're using the tool that we just ran before this, you want to test your own, you can navigate to that deep learning pack. And then we're going to select the buildings _ classified deep learning package, not pack, sorry. And then select OK. Okay, now that we've trained our model by running the trained deep learning model, we are ready to move forward to the next and final step of today's lab. If for some reason you didn't run the previous tool because you were having computer issues, this is a really GPU intensive process and it takes a lot of time. I've actually provided the results from the last tool on Canvas so that we can move forward with the lab. So if necessary, you could start Arc Pro and open your Woolsey Fire project, but you should probably already have it open. And in the contents page, let's turn off the training samples. We'll get rid of create features and modify features. Okay, so we turned off the training samples and you'll notice that there is another layer called building features. And like I said earlier, this is just a layer that you can download from most likely the local jurisdiction's website where they usually provide building layers. If not, You could create your own polygon feature class and digitize each building. That works too. But let's turn on the building features layer and let's zoom to it so we know what we're doing here. So right click, zoom to layer. Okay, and as you zoom out, the aerial stops showing. Okay, so these are just building polygons that we have here. And then in the building features layer has additional building footprints that aren't classified yet. Maybe we ran out of time, we couldn't keep doing them manually. We want to use this trained learning model, deep learning model. So from the map tab in the navigate group, let's click the bookmarks and then let's select inference area bookmark, which I had already provided for you. Now you will use the trained model to classify the buildings in this extent. So on the ribbon in the command search field, so imagery, let's type classify objects using deep learning. So in the command search, let's type classify objects using deep learning. And it should be this first one that says image analyst. So let's double click that. And that will take us to our final geoprocessing tool. So for the input raster, let's choose the USAA. Next, you will choose the features to be classified, which is that building features layer. Because those aren't yet classified. And then here's our output feature class. We'll keep the default, but if you hover over, you can make note of where you're saving this. So for me, it's in my week 13 folder, and then in the geo database for Woolsey Fire. And then in the model definition dialog box, browse to the classifying objects deep learning folder that you originally downloaded from Canvas. And then go to buildings _ classify. So that's in provided results. Or similarly, if you're using the tool that we just ran before this, you want to test your own, you can navigate to that deep learning pack. And then we're going to select the buildings _ classify deep learning package, not pack, sorry. Okay, so for the input raster, we're going to use the only raster in the project, which is the USAA imagery. Input features are the building features, which are the unclassified building layer that you can enter manually or you could download from local jurisdiction websites. But for this exercise, I provided it. And then for the output classified objects feature class, let's type inferenced buildings. So you could delete the end of the path and just write inferenced buildings. Okay, and then model definition, we're going to browse and click the buildings _ classify deep learning pack. So that'll be in, I provided these results because I wasn't positive that everyone was going to be able to run their previous tool in time to perhaps get this done. So if you didn't, you can use the provided results, buildings _ classify, and it's this buildings _ classify deep layer packaging. I'm sorry, package, not pack. Select OK. The next parameter specifies the name of the field in the new layer that stores how each feature will be classified. So for class label size, for class label field, let's select class label, and then again, you will set the batch size value, which is how many sets of image chips are processed at a time. So let's make the value 8. Okay, and that makes that warning icon go away. And then leave the test time augmentation value as false. Okay, before running the tool, you will set some environments. So let's go to the next tab over, Environments. Near the top of the geoprocessing pane, click the Environments tab right there. And so we want to make sure that the bookmark inference area is checked. And so, and then when we choose the extent, we can hover over and say current display extent. So that'll fill in what we're currently looking at. Okay. Okay, and then for the next parameter under raster analysis, we're going to select the size type 0.3. So just type 0.3. Okay. And then under processor type, set processor type to GPU. Oops. Click the down arrow and then click GPU. And then we'll be able to click run. This tool can take 30 minutes or more to run, depending on your computer's hardware. The ability to set the batch size to 8 depends on your GPU. So if the tool fails to run, try to change this parameter of the batch size to 4 or even 2. Once you're done running the tool, you'll be able to view the new classified buildings layer and see the results. So again, I told you this would take 30 minutes. I've already ran it, so I'm going to use the one that I ran and provided to you guys. But please feel free to use the tool that you ran, and you could check your own results. So on the ribbon map, let's select Add Data. And we're going to navigate to the folder that we downloaded, Classifying Objects Deep Learning. And then let's go to Provided Results. And then open the results.gdb geodatabase table, and then click inferenced underscore buildings, which is what the output feature class was that we just ran the tool for, and select OK. Okay, so in the contents pane, let's zoom to this layer and let's select it. And then on the ribbon from the Feature Layer tab, in the Drawing group, okay, so Feature Layer tab, we're going to select Import. Okay, and then in the Import Symbology dialog box, for Symbology Layer, click the Browse button. So for this one, click Browse. And we want to go to the layer that's provided for Inference Building Symbology Layer. So you could save different symbologies as a layer file and use them throughout different projects. And then select OK. The buildings inference layer now shows the damaged buildings in red and the undamaged in yellow, or kind of a neon color. On the ribbon from the Edit tab in the Selection group, click Attributes. So Edit, Ribbon in the Selection group, let's click the Attributes. And we're going to open the Attributes window a little bigger. And our layer, we want to select the new layer, which is Inferenced Buildings. And let's press play, and we can go through and kind of double check that each one looks as if it should. So this, it takes a second to load. So that one is undamaged, looks good. And so you can just sit back and kind of double check everything. This is undamaged, that looks good, and so on. Oh, and we could pause it. So we're like, oh, we finally got a damaged one. Let's take a look. If I turn this off, you could kind of tell that this building was actually damaged right next to an undamaged building. And you could change the play speed if it's going too fast. You could choose a different speed. So this is the time where you can observe how well your model classified the buildings as damaged or undamaged. If you want to change the classification for a feature, click the pause button and update the class label attribute like we did at the beginning of this lab. So even though we are using AI, machine learning, deep learning from Esri to perform this analysis, there's also a manual kind of feature that's involved, and that's just double checking the AI that we ran and its accuracy. But we can assume for today's lab that they're all accurate, even though I would not make that assumption. I would spend time to check each one. But for today's exercise, you are done. So you can save your edits. So if you made any edits, I didn't. So I will just close the attribute table. And then the final part of today's lab is just to submit this, and we will go zoomed out to the imagery. Submit this as a map. So let's kind of close this. And we want to see the damaged and undamaged building. So maybe turn the building features layer off. We can have our training samples. And you can, oops, sorry. Infographics just popped up. You can just show the inference buildings because that was the one produced by the model. So go ahead and make a map with your 5 essential map elements and label, make sure this layer is labeled so we know what these yellow and red buildings are labeling. And congrats on completing your first deep learning model in ArcGIS Pro.